Yeah, I'm not used to it as much when they're not broken, at least.
So yeah, thanks everybody for coming out. It's great to see everybody again. Real happy to have NDev back on again, getting to see people in person again. It's really good. So thanks a lot to Liam for helping organize all this stuff. He's been a great help, and thanks to Get Coding and TechNL for the space. This is a pretty sweet spot to hang out and talk about nerd shit. So yeah, so thanks to you guys for that. Rally hosted the beer and pizza, so thanks to Scott and the boys for that. Yeah, so I'm not going to talk much more. Not much further ado. Thanks so much to Mitchell Hynes for putting together a great talk on WebAssembly, and I'll let you take it from here, bud.
Thank you. All right, hello everyone. My name's Mitchell. I work at SIFT. Some of you might know it as ReportMate. They literally rebranded like weeks ago. So yeah. Hold on, I don't know when you present. Okay, you still see that? All right. So this title has changed a lot. You might see it as a different one on the site, but it's currently WebAssembly will change how we all run apps. So who's heard of WebAssembly in the room? Like just a show of hands. All right, so quite a few people, but who's actually like used it? And I don't mean like running it on your machine. I mean like maybe you made a project, compiled something to WebAssembly. Okay.
With 3JS, does that count?
3JS is not WebAssembly, but it's yeah. So I want to talk about a little bit about why this is important to me. And first, the agenda. So why portability matters, where the security fits in, how WASM is portable and secure, and where web apps could go, and why you can, what you can do to help make it happen. Okay, portability. Who remembers Minecraft in the browser? Does anyone remember playing that in the browser when it first came out? Yes. I would always, like, during my lunch period at school, I'd go on the school computers and I'd make the fans spin with this game, and it's written in Java, not a lot of people know, and it was really my gateway into what I'm doing right now, and that's because I want to make mods for it. Right, so they took away Minecraft in the browser. It doesn't exist anymore. It's mostly because we upgraded by getting Minecraft in the browser. And then, blocked by application security. Applets were basically deprecated. And that's the mechanism that Java runs in your browser. And a lot of them got blocked. Well, all of them got blocked, and then it was a sort of like really sketchy dialogue that said like, oh, more information, and like click OK, please let us run code on your computer. And yeah, the last one is kind of a nightmare scenario. Who's heard of this one? Log4j, or Log4Shell, sorry, of course. Yeah, okay, about half the people in the room. Right, so that was a really huge vulnerability, and the funny thing about it was that once it was discovered in one thing, it was discovered in almost everything. And if you should, honestly, if you're writing code today, you should probably check for it. It's really simple. You just put in a JNDI string and check. But anyway, that's a whole other talk, honestly. Okay, so JVM runs Java, and it's, well, the JVM runs Java, and the problem is the JVM. It's too privileged and capable. So the JVM is the kind of virtual machine underneath Java. And what it does is it takes your bytecode and renders and runs it. So Java succeeded in portability, but it failed in security. So what I mean by that is that Java apps are portable. There's Java embedded, there's Java on the server, there's Java Enterprise Edition. There's like different like specs around it, which is really cool. But Java was not made in the time of browser sandboxing. So what I mean by that is browser sandboxing is basically where tabs can't share resources unless they're from the same origin. So I can't run JavaScript that reads from a different tab you have open and all that stuff. And yeah, so I wanted to talk a little bit about the brief history of time portability. So, how was portability done way back when? Okay, history lesson. POSIX. So POSIX stands for Portable Operating System Interface. Who's in this picture? Does anybody know? No, not Steve Wozniak. This is not Apple.
Yeah.
This is
Kernigan and Ritchie.
Kernigan and Ritchie. It's actually Ken Thompson.
Ken Thompson.
That's a good guess. And what's the computer that programmed it? It is a PDP-11. Good one, Jack. That's cheating because I think I should. All right. So, what is POSIX? Who can answer this question for me? I feel like it's a very broad thing. Does anybody have a definition that they want to try? You're wearing a Unix shirt. You better answer.
So when I think of POSIX, I think of the shell syntax and interpreters. I don't necessarily know that is the all-encompassing definition of POSIX.
You're right, and that's not all-encompassing. But yeah, you're right. The shell syntax are like basically what you would consider bash scripts, and the bash scripts aren't like necessarily POSIX. Anything with like a .sh, that's definitely POSIX. Okay, so what POSIX is POSIX defines both the system and user level APIs, along with the command line shells and utility interfaces for software compatibility, portability, with variants of Unix and other operating systems. And there it is, a standard. It's a white book, and it's got a lot of things inside of it that tell you how to make something POSIX compliant. All right, I promise I'm going to stop asking like whose people's names are and like history stuff. But who's this guy? Does anybody know? Bill Joy. So, right. So this man could open a MacBook and find code that he wrote decades ago. He's had such an impact on like computing at large today. It's pretty insane. So Joy devised a version of the Unix operating system called Berkeley Unix that used the TCP/IP networking interface, which placed Unix servers at the forefront of the internet revolution. And BSD provided the basis for several open source operating systems, including FreeBSD, OpenBSD, NetBSD, Dragonfly BSD, Darwin, and TrueOS. And these in turn have been used by proprietary operating systems, including macOS, iOS, which derived from them, and Microsoft Windows, which used at least part of its TCP/IP code. Code from FreeBSD was also used to create the operating system for the PlayStation 4 and the Nintendo Switch. So I want to tell a little story about this and how he actually wrote that TCP/IP code, because it was really important. So TCP/IP is basically the protocol that allows you to share packets with like other computers, and that was pretty huge back in the day. That was like the next thing, was getting computers that connected to the internet. There's this company called BBN, and they had a DARPA contract to implement TCP in BSD. John Gage tells it, BBN had a big contract to implement TCP/IP, but their stuff didn't work. And grad student Joy's stuff worked. So they had this big meeting, and this grad student and a T-shirt shows up and says, how about you do, sorry, I'm reading this completely wrong. And they said, how did you do this? And then Bill said, it's very simple. You read the protocol and you write the code. So Unix like, it sounds so easy, right? Okay, Unix-like and POSIX computers serve the internet. So POSIX became the standard for making systems today. POSIX-compliant systems run the internet. POSIX-compliant systems also run apps on Android and pretty much every Internet of Things thing. All right. So you think you're POSIX. What's your favorite operating system? What do you do most of your code on?
Arch Linux.
Arch Linux, okay. How POSIX compliant do you think Arch Linux is?
Better than most, but not perfect.
You're right. So let's see what Wikipedia labels it under the POSIX compliant chart. It is under mostly POSIX compliant. So give me another one, another popular operating system maybe. That's not Linux.
Mac OS.
Mac OS. So
Well, Darwin.
Darwin. Okay, so that is actually POSIX compliant. Like all the way up there with Euler OS
Euler.
and Open Server. Cool. All right, and then there's the chart. So all of these systems have to implement POSIX, basically, if they want to have apps be easily ported over to their systems. So we have the web, which is portable for God's sake. So we have sandboxes. I gotta go out of presenter mode and open it like that because it was slides. All right, so websites are portable by nature, but WebDev is hard. Oh wait, I think I've lost. Yeah. All right. So sandboxes allow websites to use system resources without arbitrary access. It's different from the JVM, and they can't access each other's data either. So that's security. And no, people had code in the browser that ran fine. Why not run the same language on the back end? So you could share your code that was running on the browser to the code that's running on the server, and you can hire like JavaScript developers to write code on your browser and write code that runs on the back end. This is a caveat. Chrome splits every tab into and plug an extension into its own process, which is really hard on your system resources, and it uses a lot of memory. Plus, it's not always that portable. If you run a native app that runs out of the browser, Electron is recommended, but that has similar problems to Chrome. Who used Atom? Right. Yeah, and they killed Atom. It's, he was just 9. It was deprecated it's being deprecated this December. So Atom was the precursor to VS Code. It started this whole Electron revolution, which is like, oh, you want to build an app that's outside the browser? Why don't we just ship a small browser? Right. So some app frameworks use web views. There's like new ones like Towery and stuff like that. And the idea is that your operating system ships with a browser like Safari and Edge. And the idea is Edge is kind of just Chrome, but now it is. But yeah, the idea behind those is that you can run a browser in your operating system and not have to ship a browser for every app. Basically, you kind of bootstrap yourself off the browser's operating system, but that has other problems. So are websites the best way to make web apps? I actually have another So this is a question that I posed to you guys. Are websites the best way to write apps? Think about that for later. And then there's Atom. Oh, it was so flashy. And like, the color scheme I always liked. It was kind of muted. And yeah, I remember running this on my Surface Pro 3. It was my first like real coding job, and it was a text editor, and it blew my mind how like when I opened the text editor, my fans would spin up, and it was like it's taking off. All right.
I was just telling him the same thing. When I use that, my fans sound like this because I can hear
No, I think it's me.
Yeah, and then VS Code struggles to open like a 30,000 line file. I'm like,
if you had it in like VM, where if you're using it in like a VM, it would. If you had vector graphics turned on, it would explode.
yeah. But hey, it was just a precursor. Look at what we have now. Your VS Code. Right. Okay. So what the people want. So what devs want is a load and runtime efficient format that's portable, virtualizable, language agnostic interfaces. They want language neutrality, so you can use the right tool for the job. They want embeddability, so browsers, servers, intermediaries, small devices. Formal semantics, white papers, and not the cryptography. So Java was that, basically. But it had problems with security. So what the users want, they want apps to be accessible anywhere. When installed natively, they want native functionality. So more power over the hardware in the system, and Discord is really limited if you use it in the browser. Yeah, so users expect native performance. Am I missing anything? That's a short list.
Users don't want their RAM getting eaten up by Chrome.
That's true. Yeah, but I feel like very few times people open their task manager. But I think they would notice if like their laptop was like pretty small, like on like a phone, right?
They want their apps to launch quickly.
That's true too. Yeah, they want their apps to oh my. Jonathan Blow made Braid and The Witness, and he complained. He made an entire talk that was just complaining about Photoshop pretty much, and he was like, "Oh, why does it open a splash screen?" It's like, go back to making games. All right. So, state of the art. So you build a web app with 100 kilobytes of CSS, 100 kilobytes of HTML, and then 20 megabytes of JavaScript minified to 2 megabytes, so it's fine, right? Okay. You realize there's missing functionality, push notifications, there's limited audio APIs, poor video to decompression quality, and you limited access to hardware features. So you create Electron and take everything outside the browser, and then you code a little extension to Electron that allows Electron as an actual process on the machine to do those things, like use your actual computer's hardware features and different things, and parts of your operating system. So side of this actually works really great. You can build all sorts of native experiences in Electron, and people don't even notice. It's just code, pretty much. So Discord, Slack, Notion, more do this. I want to talk about an alternative. What if you built a native app and then brought it to the web? Think about that. Okay, so you can code in any language you want and bring it to the web. That's what WebAssembly does. You don't have to write JavaScript to code an app anymore. Although you do have to write JavaScript to glue, but we'll talk about that after. Okay, so WASM is more common than you think. So I don't think a lot of people know this, but the W3C stack for WASM has been implemented in the 4 major browsers since 2017.
Should be big fat asterisks next to that. I gave a talk in, I think, 2018 about the acceptance to that claim.
Oh, yeah. Interesting. Acceptance to what aspect of it?
It was not implemented. It was implemented partially.
Oh, partially, okay.
Safari did not.
Of course it was Safari.
Yeah. Well,
probably still does.
No, it does. Safari is now probably the best, most compliant browser of the big four. I would say Edge is the worst. Chrome was there in 2017.
Yeah, Chrome likes to make standards and not to follow everybody else. Right. So there is ASM.js. So ASM.js was a precursor to WebAssembly, and the idea was that like you could compile things to ASM.js and then bring them to the web. That's a whole other topic, like the evolution of WebAssembly, like where it came from. WASM is meant to bring more languages to the web. That's what it is at its base, and bring them perform with a native, close to native performance. It's not just for people who don't like JavaScript. So the origin, like I said, of WASM was ASM.js, which allowed people to compile huge C and C++ code bases to the web and deliver them worldwide. There's this demo, I can't find it anymore, but I think it was like the Unreal Engine compiled to ASM.js and running in the browser blew everyone's minds back in like 2015. The web's job is to make the world's information accessible, no matter what it's written in or how it's made. So what is it literally? It's an assembly format that browsers can read. What is it in practice? It's binary. So take a look together. Pass my entire screen. Okay. It's working. here we have the WebAssembly Code Explorer. We can look at the WASM binary in all of its glory. So this is what you need to ship in order for a browser to consume your code, and it's binary. So on the left here, if anybody used hex editor before, so on the left here is just the binary, and this is what it looks like when it's turned to strings. And over here is, I believe this is WIT, which is a kind of like intermediary format between code and this binary on the left here. So it's more readable. Now this is a hello world. And notice here that it has an import. And that import, the purpose of that is that the WebAssembly modules have the least amount of privileges possible. So the modules themselves don't really do much. They don't have access to basically anything. WebAssembly is just kind of WebAssembly interpreters just interpret the bytecode and try to run it. And if the bytecode tries to access something outside of the code, then like it's almost like it's non-existent, and you get errors and things like that, like null pointers. So this is a function here. It says import sys print. So the idea is that you have this import, and you can call it there with hello world. This is pointing at hello world and all that stuff. Anyway, that's kind of a deep dive. Very, very shallow deep dive, but a deep dive. This is awkward. And stop. Cast the tab. All right. So, like I said, it doesn't really have access to anything. That's where glue code comes in. So the idea behind glue code, this is a Rust program. Nobody's seen Rust before. But this is glue code. So glue code, the idea behind it is that it's a sort of interface between the system that the binary is running in and the binary itself and the code that's running. So how do you run WASM in the browser and then have it access something like the DOM, which is the HTML on your web page? Well, you have this WASM bindgen, and WASM bindgen allows you to bind all sorts of things in your browser to your code. And you can see here what we're doing is we're checking to see if everything's like there first, and then here we have this document.create element p, which looks a lot like the JavaScript version of that. And then we just set the value to some text. And then we append it to the body there. It's a lot more involved than the actual JavaScript version, but that's because it's Rust. All right, so where does glue code get us? WASM itself isn't that powerful. So you need something on top of it to give it resources. It doesn't have resources itself. All that it really has is a heap, stack, data, and code, and then we have this glue code between it and the web page. So if I have a web page that rotates a 3D cat, great example, right? Very practical. I have this JS glue code that basically gives my web browser instructions. And then the WebAssembly runtime is like doing all the busy work and running some maybe proprietary code written in like C and C++ that I couldn't easily port over to JavaScript, for example, and then calls all the functions in the web browser in the same way that JavaScript would. So you're still limited to using web APIs like WebGL and I'm blanking. What's on the web API? The DOM. That's a web API. So what if that glue code, we could just swap that out. So then instead of it calling to, say, WebGL or the DOM, it could call to some other binary that I made, or some little interface to your operating system. So I could then compile my WASM. I don't even need to change it. Just compile it once, and then this interface changes. I mean, the interface doesn't change, but the thing behind the interface changes, and the interface itself just stays static, which is really cool because that means that our apps are truly portable. Emscripten. That's basically an interface. So Emscripten emulates POSIX and many other things. So they do APIs like it converts OpenGL into WebGL. It has support for APIs like SDL, pthreads, POSIX, as well web APIs, and JavaScript. So you can compile basically any C++ app, very huge asterisks, but like simple ones that have like GUIs and like access things like your graphics card. You can compile those to WebAssembly with Emscripten, and you can get that glue code generated for you by Emscripten, which is really nice. But WASI has its own Emscripten. And it has its own, I mean, WASM has its own POSIX, you could think of it like that. So WASI equals POSIX2, escape to Madagascar. So here standardizing WASI, a system interface to run WebAssembly outside the web. If you want to dig into how WebAssembly does all of what I just said, and also where it's going in the future, and how it's going to deal with things like POSIX, you should read this. This is actually this is kind of like the article to read about WASI. And it has all these little doodles and things like that. It's very easy to read and very entertaining. So WASI is trying to do a lot, but not everything. So it makes compiling easier. So you can access like things like files and networking. And then your app is portable across runtime. So you can bring it from the OS to the browser, and it uses the same interface for accessing files and networking and things like that. And this is what POSIX wanted. I want to talk about security and portability and how they kind of mesh. So you isolate responsibilities, and WASM modules can only use what the host provides, which also means it makes no assumptions about the system that it's running. But that doesn't have to mean that your code needs to be platform dependent. Like look at WASM. So security requires gaps between your code and the system, and those gaps make your code easier to port. So the WASM, that means that that your code works really well in a cloud and edge environment. So who here has used Docker before? I'm assuming like almost everyone. Who here has made Docker images? Okay. Would you say it's easy? It's user-friendly?
Depends what you want to do.
Compared to making Windows images?
Okay. But maybe not. Maybe not comparable.
Bar.
Yes. Bar is here, yeah. Yeah, so Docker images are actually kind of hard to make that are like cross-platform. So like you're still compiling and making sure that your image works on an architecture. So the premise behind Docker, for those who don't know, it's like I have something that works on my machine, so I'll just ship my machine. So that's basically what Docker is. It's like it isolates all the resources around your app so that like whatever code that you're writing can be picked up and put wherever. So this is an infamous tweet. It needs to be in every WASM talk for some reason. Every WASM talk that I've seen has it there. So if WASM plus WASI existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing. Standardized interface was the missing link. Let's hope WASI is up to the task. So it's kind of infamous because WASM and WASI couldn't exist in the time that he created Docker. And yeah, they could kind of replace a lot of use cases for Docker, but Docker and WebAssembly kind of work hand in hand in some scenarios. Yeah. People don't often quote the follow-up tweets as well, where Solomon sketches out running WebAssembly inside of Docker, and Solomon understood how promising WebAssembly is, but did not believe it would actually replace containers. So, yeah. Very cool, Mitch. Looks like a bunch of crud. What can I make with it? Well, I made MitchellHynes.com. So this site is now powered by WASM. So this site you can visit, and it's running WASM serverless. So it's MitchellHynes.com. And you can visit this site, and you are hitting endpoints that run WASM. Yeah, so this is the halfway point. I'm going to let everyone get up and stretch and not listen to Mitch explain for a little bit longer. get your ears a rest. Yeah, and you can come up and ask me questions, and chat for a little bit. But yeah, that's the halfway point. Cool. Good to go. All right. So this second part's mostly demos, and it's basically a collection of cool things that I think that you could do. So this is the end part of the talk here. It's going to be short and sweet, but also kind of hectic and less structured. So if I go next here, so this is a really cool implementation. So because WASM's capabilities are basically up to the host environment, you can embed WASM into things like microcontrollers. So this is a Pico display. This is a Raspberry Pi Pico, which is basically the smallest Raspberry Pi you can get. This is a demo of the Dino game for the Raspberry Pi Pico. If you've ever played like the Dino game on your web browser, it's like when you have no internet and you're looking for something to do. So you just press spacebar on that little Dino and it jumps. And yeah. Anyway, so this is a port to WebAssembly, and it runs on a Pico. So WebAssembly can be embedded. There's also WASM 4. So I really like WASM 4. The idea behind WASM 4 is that it's a fantasy console. So it works with imaginary limitations. And the cool thing about that is that you can build games that aren't on like a modern game engine. Because a modern game engine will distract you with all the features that it has. And then a fantasy console doesn't, because it's got very limited capabilities. And I should have this open. It's in the let's see here. I'm just going to pass my screen. It's probably easier. All right. These are the beefy specs for the WASM 4 fantasy console. Displays 160 by 160 pixels. We've got 4 customizable colors. It updates at 60 hertz. 64 kilobytes of linear RAM. You've got save states. Cartridge size limit is 64 kilobytes. So you can use the keyboard, mouse to touch screen. There's audio. So there's 2 pulse wave channels, 1 triangle wave channel, 1 noise channel. And the idea is that in the future there could be some sort of embedded little handheld device that you could play these WASM 4 games on. And that's because WebAssembly is so nice in the sense that you can move it from different. You can port your app to different devices. And it really depends on what your device's capabilities are. So a fantasy console fits really well with WebAssembly. And I encourage everyone to check this out later, especially in this community section. So these are the winners from the last Game Jam, and you should test them all out, because they're all surprisingly good for what this little console can do. All right. So WebAssembly, the browser, of course. This is Unity. So you can make a game in Unity and then compile it pretty easily through their UI to make a portable version in WebGL, and it runs in your browser. So most of the engine gets compiled to WebAssembly, probably through Scriptum, and then gets ported to the browser, and you can run your games portable. And there's PyScript. Has anybody heard of PyScript? It's made the rounds in social media. Okay, 3 people, 4. So it allows you to run Python in your HTML. So similar to a script tag, you've got PyScript, and then inside of it you can just do print. And there's your Python. When this first came out, this is a funny story. When it first came out, there were a bunch of people on Twitter who thought that they were like hacking into a remote system. They were like, oh no, I can do ls/ and I can look at all the system's files. But that's not what was actually happening. It was just emulating listing the root directory on a POSIX-like system. And that's because that's what Scriptum does. PyScript also uses Scriptum to port a Python interpreter over to the browser. Okay, Doom. So Doom was compiled to WebAssembly by a team at Cloudflare. So I also encourage you guys to play this, because this is like pretty freaky. Playing Doom in like a little browser. window, and that's compiled with the actual Doom source code and using the original Doom assets. And there's multiplayer support. Of course, it runs on Cloudflare Edge's network. Using workers, web stuff, it's durable options. All right. Now this is the best one, I think. So I've played with this quite a bit, and it's become the love of my life because it's an immediate mode UI library called eGUI, and this is something you can literally open on your phone, and this is all in the browser, by the way. That loaded very fast, right? And if you inspect elements, let me just remember how to really inspect, or I can just maybe there's development tools. Okay, there we go. So there are no divs in this website. Well, there are divs, but they are. Oh, it doesn't look like there is actually. No divs, just a canvas rendered with WebGL. So this canvas in the browser is rendering all of this UI, and they have coded an entire GUI library around that. And it also works, when compiled natively, it works using your actual hardware graphics API. So that would be Vulkan in some systems, OpenGL on some systems, Metal on this thing. And you can click links in it, which I think is pretty crazy. You can go to the demo section. This is the best part. So this is the first screen that you see when you look at the when you look at their GitHub, the link on their GitHub. It's called eGUI, so eGUI. And it's got all sorts of widgets on the right here, like they've got plots, they've got sliders, a Bezier curve editor. It feels super responsive. It's got a screen reader built in somewhere. Yeah, this has been jarring. Hold on. It's got a ton of features, and it feels almost native as you're using it in your browser, which I think is, at least for me, it's very interesting. And it's created by this guy's company, eMilk. So he has a startup called Rerun.io, and so Rerun is a visualization tool for developers working with computer vision, robotics, and anything 2D and 3D. So you can see they've got like a point cloud here, and then they've got this like view here. This is a video, by the way, if you go to the actual tweet. And then right here, they've got this timeline widget that they made. They got a histogram, and this is all running on this in this native app there. And the dream for them is to compile that native app and run it in the web browser. So it's the kind of reverse of what's been happening, which is making a React app or making a JavaScript app and then moving it to the browser via Electron. And I think that's really exciting. Right. So the future of WASM will enable lightweight, secure, portable apps in any language you want. There's one last demo. It's kind of a freaky one. I hope it doesn't spoil it. But, all right. So Qt, huge. It's love it or hate it, Qt in the browser. And this is LibreOffice. To be honest, this is leagues ahead of any other editor that you can get in JavaScript right now. But it's also, this is a beta here. It feels pretty nice as you're editing it, and it's got most of the features. There are some things that make it crash, like if you try to open a file, I think.
That might be important.
Edge cases.
Edge cases, opening files. But that doesn't mean that it doesn't have access to files, right? They're just missing a few things, right? And you can, it's open source. You can contribute to this if you wanted to and help it get past the line. But most of the features are there. You can insert tables. You can edit images and all that stuff. I was playing with it earlier, and it's pretty amazing. So that's it. That's all the demos. I have many more, but I feel like I could go on forever. So you can get me on Twitter, GitHub, my website's there, and my email. If you guys have any questions about things you might want to build in the future, you can talk about it after. I'll hear all your crazy ideas. And yeah, I hope you guys learned. And that's the end of the talk. Thank you.
Anybody have any questions? Willing to answer some questions? Yeah, Mike, what's up?
So this is a question that came up when I was looking at Wasm the first time. Are you still bootstrapping JavaScript again? Is Wasm still at the phase where it's mostly a library that you access from the JavaScript application, or can you put a full-fledged Wasm application on a page and work with it and have some JavaScript that you interact with?
It's still in that weird state where it needs, like a WASM module needs to be bootstrapped by JavaScript, and then that also is where it gives it its capabilities. So, yeah, it's still at a really awkward phase. But as time goes on, and this is what they said, but first, everyone, all that stuff. And as time goes on, it's going to get native access to DOM APIs and things like that. So it doesn't have to go around through JavaScript to get DOM APIs and stuff. But out of the browser, in WASM time, for example, which is a command line app, really, and also a runtime for WebAssembly modules, you don't need to write any JavaScript. And it runs it as if it was a script in your terminal. So you just type WASM time and the name of your WASM executable, and it just basically works. And it runs whatever code that you want. Now, WASM native outside the browser, all that stuff is a whole other topic. Any questions?
So it's like, okay, this is going to show my ignorance. So you're compiling these binaries. You're not feeding these binaries to like V8 or like the K and whatever Safari uses or anything, right? Like the browser's like basically just shunting that to the CPU to run. Is that?
So it's sort of like a virtualization.
Okay.
So yeah, how does it actually run the byte code?
Yeah.
It's an interpreter.
Okay. So it's separate from like the JavaScript interpreter.
It has its own memory, and
Okay.
it has its own. It's got its own heap, stack, everything, and like that's all emulated underneath. And the idea behind that is that you could have WebAssembly, a WebAssembly module that doesn't really have that has like emulated access to system resources. It's not running with actual system resources. It's kind of like really. That's the idea behind it.
I think I'm getting to the point where the Destroy All Software talk, the birth and death of JavaScript got to, where like you like compiled like Docker in WASM to compile Windows to run it in a VM, to run the VM in a Docker container that was compiled in WASM, so your browser is just.
Yeah, that's probably like 16 layers of scripting.
Yeah, that's good. That's good stuff.
Yeah.
Sweet.
So I guess we're currently in the Clone Wars phase of that talk.
Yeah. Yeah.
So I guess on that note,
Sorry, go ahead.
So I guess what would you say is the interpreter for like WASM? So like does it get interpreted directly by an engine like V8, or does it simply get interpreted by some other interpreter that is initiated and bootstrapped into an environment by something like V8?
Both things are right there. So you can code your own WebAssembly interpreters. And the idea about, and like, yes, V8 has its own interpreter, but there's also other ones like WASM time. It's pretty easy to make a WebAssembly easy, but it's pretty straightforward to make a WebAssembly interpreter. And the interpreter is the thing that runs the WebAssembly module. In the case of like browsers, it's normally something that's built into the browser's source code or the JavaScript engine. Like if you build a JavaScript engine, you're probably going to need to make a WebAssembly interpreter. So that's generally the thing that actually runs it. In the cloud and things like that, it's typically like either WASMer or WASM time. Those are the two big interpreters right now. Yeah. Any questions? Oh.
So I'm old. I'll preface this question with
Pish pop.
Oh, sir, you're a young child. So, I mean, Java tried this, .NET tried this, and tries it more every year with .NET Core and all that stuff. You know, so why for those of us who survive like 4 generations of interpreted bytecode that gets just in time compiled to portable format? You know, like why is WASM going to win this? Is it because we have the browser manufacturers behind it? Is that like the big strength?
I think it's going to go further than others did, simply because it's not. And I could be wrong, but I don't think it's built the same way as .NET and as Java was. It's being built as part of the browsers, like you said, right? And it's not there are companies pushing it, but there isn't a single company behind it that's kind of it's not Microsoft or Sun, you know. It's Apple, it's Google, it's Mozilla. Sorry, I almost said Firefox.
Do you think that there's a lack of fragmentation there that's true for the other one? Because that's the only thing I can identify. Like Java fragmented between the Oracle official version and the Open SDK version and all that.
Yeah, that's true. There are multiple versions of it.
And like .NET Core is coming from the other side of that, where they're trying to be more open and be more in the specification. It's also it's also not trying to do everything. WebAssembly is simply a standard for interpreting bytecode. And well, not really, it's kind of an assembly format. But then underneath it you need to build things and interpret it. And it's single responsibility, really. And there are projects like WASM that give more capabilities, but like it's not trying to do a full app framework like Java did and .NET did. It's just, here's a standard for you to write code in a browser that's not JavaScript. Okay, we got that done. What you're saying is the ways in which WASM currently resembles writing a simpler language is the future, not a bug.
Yeah, maybe. I'm trying to say that it's an isolation of responsibilities.
To add to Mike's bit, I think it's more like, you know, if you're writing Java that compiles Java bytecode, you're doing, you know, it's kind of an output of Java. You're writing C# for that, something that runs in .NET Core, that's C#. With WASM, you can take your C code and do Rust, there's Go, there's some WASM specific languages.
Like, there are so many compilers that try to code one kind of thing.
But there's still
anyone who's my age or older has been through this. Like I said, 4 times at least. So like every compiler, including Python, has gone through this. I'm really curious to see. Like I am too old to be invested in that, but I'm really interested to know why this time it will work.
And LLVM did a similar thing too, right? They had the like intermediary layer that you could like take any input.
And maybe LLVM is part of it, right? Because LLVM opens that up in a way that it's not being opened up before. I didn't think about that, but that's a good point too.
I was thinking about this whole thing recently too, just about like website stuff. I saw Remix, the React thing. I was like, oh cool, we're templating pages again. All right, sweet. Everything's old and shitty's new and fast again. Cool. And it's just like it just goes around in this like endless cycle.
That was my exact response to it too.
Yeah, it's pretty.
But like Next.js was doing it like server-side.
Yeah.
Server-side a long time ago. Like I think it's like a year older than React.
Yeah. Anyway, we just keep going around and re-implementing the same problems and fixing it. It's great. It's good stuff.
Hey, I mean, as long as you learn from our mistakes.
Yeah. Some of them.
How are we?
As long as we get paid for it.
More important.
Any other questions? What's up?
Kind of like furthering this note again. So we talked about Docker and how like it's difficult to build Docker images. So I want to dig a little deeper into that. What would you say is like the advantage of something like WebAssembly over something like Docker that basically tries to do the same
I see what you're
thing?
saying.
Yeah.
So let's look into what you need to do to, if I made a server in Rust or C++ or Go, What would I need to do to make a Docker image for that? And you have to compare that to what would I need to do to make a WebAssembly binary. With a WebAssembly binary, if you can get its runtime to basically result in a binary that you can run in whatever specified interpreter you want, then you're done. With Docker, it's, okay, I need to write my Docker file so that it begins at the top and then installs all the dependencies for it to build it, if you're building it inside of it. And then you need to, after building all of the dependencies, you need to link all those dependencies kind of to it in this image and then make sure that like some things are added to the image or not. And then the image is basically shipping a machine to run your app with a bunch of unnecessary things.
So the part of unnecessary, I guess, is like arguable because really I see Docker as a superset of what you get with a WASM interpreter. So a WASM interpreter will be able to run the code for you, but it doesn't guarantee that you're running in the same environment. That's sort of what Docker offers.
So it kind of becomes the environment. The interpreter is the environment, and it can expose things like system resources to your binary without the binary having to kind of reach out to system resources through other means. It's hard to explain.
What about third-party dependencies that cannot be compiled into the WASM binary that your application may depend on?
That's true. There are third-party dependencies that like make it hard to compile, but you can reach for other things that will, or you could build your own. Like there are certain cases, yes, like Go, you have to use TinyGo, right? So the entire the standard Go compiler probably won't make a runtime that's portable enough to run in WebAssembly. But there are alternatives like TinyGo. TinyGo allows you to compile your Go code into a WebAssembly module, and assuming that it's running in a WASI environment, then it can access the system resources, and it's almost indistinguishable from like writing code for the standard one. But you can't use all of like the entirety of Go's packages. You have to use like the ones that will probably compile.
Yeah.
So in Rust, this is an easier. It's generally an easier thing to do with Rust because Rust it's really common for people to be writing Rust and WebAssembly in Rust, and that language it's pretty seamless. It's actually like staggering the things that you can compile that are Rust crates that just work in WebAssembly because they don't access that many system resources.
There's also the issue of different WASM interpreters. Like, is it guaranteed that every interpreter will interpret your bytecode in the exact same way? Or do you have to like test it against different interpreters to make sure that it works?
Yeah, that's a good point. Will my code run the exact same on different interpreters? Generally, that's it depends on the interface that interpreter would expose to your module.
Mm-hmm.
It wouldn't really like I wouldn't do like 1 + 1 = 2 on one, and then like it would give me 3 on another.
Yeah.
Like stuff like that. But if I try to access this this system on this interpreter, like for example, if I try to list files in a directory through the interpreter, so the interpreter is giving me a function to like list files, for example, in a directory, that might be different depending on the interpreter.
Or maybe as like browsers start to implement different DOM interfaces, like to the WASM interpreter, you start to need using like some kind of like can I use library to see what interfaces are available to you in different browsers.
Oh yeah, but that was true. Yeah, that's true. But what I'm trying to say is that generally the things that change between interpreters are the system interface, and that's where things like WASI come in, and also standardizations around WASM that are like proposed and like slowly but surely, hopefully, being implemented that give your modules more power. I could talk at great lengths about system interfaces in WebAssembly, and yeah, I think that if there are generic ways to access system resources, whatever that might mean, then yeah, it should be very seamless. Yeah, and that's been said in the past for other things.
Yeah, of course.
Try to change the world, gosh darn it.
That's cool. It's very cool.
Yeah.
Sweet. Well, thanks again.
Here's one more question.
One more question.
Hello, my name is Freddie.
Oh no. Has debugging got any easier with WebAssembly? Because when I worked in the past, it was a system of like, I was using Rust and I would have to connect to the web API to do console logs and my inspector just to make sure everything was fine. And that wasn't a lot of fun. And
Yeah,
the funny thing is, since web APIs are slower than just like using it through WebAssembly, I didn't realize how much slower my Rust code was because of it until I accidentally left some in. Anyway, that's a random side tangent. But I remember looking at the past that there was groups within like the committee that was like looking into like better debugging. But I'm still traumatized by that I was looking into WASM as part of writing like a thesis statement, a thesis paper for like my honors, and I don't want to think about that anymore. Has debugging got any better? That's the question.
The fact that it was like, you can't experience the best.
The answer to that is I don't know. I wonder if you can connect something akin to GDB.
Yeah.
I'm sure that if you were to expose an API similar to GDB, then from your module, you should be able to debug it as well as any binary running in your regime. Yeah, but then you also have to have GDB in the browser. You're giving me ideas.
I'm sure there's like going to be hordes of upset people that will jump on this problem though if it becomes one.
Yeah.
Yeah. I wouldn't be surprised if like there's some GDB thing going on already. That's like cool.
Can't open files, but otherwise.
Yeah, I guess it depends. I think if it's in the browser, it's very unlikely that you'll find a thing that basically lets you walk through like an interactive debugger. But like if it's in WASM time, or I just seen there's another one, WASM 3. That's another interpreter. Not WASM 4. That's a game. That's a game framework. WASM 3 is an interpreter. I know.
I love computers.
Great name.
Framework all over.
Yeah. And
You just gotta code the work.
yeah.
Not having to work.
Yeah. That's the last time I ever won. My code just works for scratch.
Scott, have you seen any examples of using WASM to make like just a small component in the web app and like incremental adoption? Like we were talking the other day about document editor. And, we have a document editor in Rally, and you guys have one too. Have you seen an example of someone just being like, I just want to use WASM for this one small component in more traditional web app? And
not directly.
Yeah.
Colab inadvertently through a third party uses WebAssembly.
Cool.
The viewer is TechSoft's, so confidential information. I think it would be.
Technically, they had some good things on there.
They do viewers for 3D engineering models and Hoops web platform. So this is just going to open an example here. Boom! Look at that. WebAssembly. WebAssembly, yes. I'll even prove it, and I'll show you guys how to prove it. You inspect.
Scott, another one that you can look at. If you look at Caltex's website, they have a spell check feature, and that at one point, at a couple of different points, they're doing WebAssembly. It's a lot faster if you can do something intensive like that.
All right. There we go. Engine.wasm. So
I guess you just provided a binary and pointed at a canvas, right? So
there's a lot more to it than that. But yeah.
Cool.
Oh yeah. Oh, for like bootstrapping. Yes.
Yeah.
I thought you were saying.
It's the making the binary part that's hard.
Yeah, I was going to say.
Maybe we can take a picture.
Okay.
Because
my phone is currently being a camera, so it's going to be somebody
I
else's
can bring
phone.
up my phone. And people can vote this down if you want. The picture on the meetup page.
It's great.
It's excellent. Do you want to do that? Because we have, 3, 4 people here who are in that photo? Maybe.
What wasn't my talk actually?
I think it might have been
If
your
it
talk.
was, then I vetoed.
You didn't hear it.
I have no idea.
Alright, so what was the photo? Are we taking a new photo or are we keeping that one?
Oh, I think
Let's
take a new photo. Yeah.
You're all here anyways.
All right. Yeah. Sweet. Thanks again, Mitch, for the talk. It was great. Good discussion. Thanks again to.
Pretend that we're watching Mitch talk.
Yeah.
We'll just be like.
Everyone be really in depth, like really thoughtful.
It needs to be a selfie, and it needs to be like turned this way with something. It needs to be an exact.
I've tried to do this before, and I almost got fired by MC.
Let me just look up the. Let me just look up the original here.
Oh yeah, we
What does all have?
Are we going to recreate your top one? Because you click that.
There it is. Oh yeah, you gotta just be.
Oh boy. Okay. Anyway.
And it's too bright too. It's like,
Oh no, I actually did the video. It says.
Phones are too good at this point.
he's like in that corner
There you go.
there.
Yeah,
like
there you
that.
go.
Yeah. Okay. Got it.
Nice panorama.
So.
If you blink the screen, you'll get rid of the projector light.
I go this way.
Oh yeah, sideways.
Oh, this way.
Landscape.
Sweet.
Excellent.
Thank you for all your good humor. So thanks again to Get Coding, Jan, Zahans, Tekanel, Liam for organizing all this and rallying for the food. And thanks to all of you for coming out. Is there anything going on in the community that anybody would like to pitch or pump up? I know the CTSNL folks said that they're having weekly get-togethers again, so hit up CTSNL and go hang out there and do some group coding, debugging, talking. Yeah, Jack?
There's B-sides next month.
B-sides. Yeah. So check out B-sides. There's a link to it in our NDev and NDev Slack. But yeah, just reach out on general Slack or something like that, and somebody will get you to the invite page. You can't find it on Google.
Matt Middleton.
There you go.
Yeah, I think it's just B-sides.
Message Matt Middleton. He will respond.
Yeah, there you go. B-sides is always a good time.
I think they're sold out of the admission tickets. There's a wait list.
Okay. Get on the wait list. Sweet. Awesome.
All right.
Thanks, folks.
More pizza, more beer, more drinks.
Talk
Please
amongst
eat and
yourselves.
drink, and